There's a rule in the ocean that most people don't know about, and it's simple, brutal, and absolute. The deeper you go, the weirder things get. Near the surface, sharks look like sharks. Sleek, streamlined, recognizable. The great white, the hammerhead, the tiger shark, apex predators built for speed and power. They look dangerous, sure, but they look normal, like something that belongs on Earth. Then you descend, past the sunlight zone, through the twilight zone, into the midnight zone where light dies and pressure crushes. And the sharks you find down there, they don't look normal anymore. They look wrong, alien, like something evolution designed during a fever dream. 6-foot jaws that unhinge and shoot forward, eyes the size of dinner plates glowing in absolute darkness, eel-like bodies covered in teeth, skin so soft it's almost transparent, and prehistoric features that haven't changed in 400 million years because down there, in the crushing void of the deep, change isn't necessary. Perfection is. For 450 million years, sharks have dominated every corner of the ocean. They survived 5 mass extinctions, outlived the dinosaurs, watched continents drift apart and collide, and in all that time, they've had the opportunity to adapt to every possible marine environment. Some became apex predators of the open ocean, others became deep-sea specialists, living fossils dwelling in places where sunlight is a myth and pressure would liquefy human tissue. And the deeper those sharks went, the stranger they became. Because the abyss doesn't care about streamlined bodies or speed. It cares about efficiency, about survival in an environment so hostile that being normal is a death sentence. So let's descend into the darkness, into the cold, into the crushing depths where sharks stopped looking like predators and started looking like nightmares. Because what you're about to see isn't fiction, it's evolution, and it's absolutely terrifying. We start near the surface, the sunlight zone, 0 to 200 meters deep. This is the ocean most people know. Warm, bright, teeming with life. And the sharks here look exactly like what you'd expect. The great white, up to 20 feet long, gray on top, white below, built like a torpedo. Counter-shading camouflage. When you look down, the dark back blends with the deep water. When you look up, the white belly blends with the sunlight. Perfect ambush predator. The mako shark. Even faster. Streamlined to perfection. Capable of bursts exceeding 40 miles per hour. It hunts tuna and swordfish. Prey that can outrun almost anything else in the ocean. So the mako evolved to be faster. The blue shark. Slender. Efficient. Migrating thousands of miles across open ocean. Following food. Following temperature. Living a life of constant motion because stopping means sinking. These sharks are built for the surface, for speed, for open water hunting. And they all share common features. Streamlined bodies, 5 gill slits, dorsal fins positioned high on the back, mouths that don't extend beyond their skulls. They look like modern sharks because they are modern sharks. The end result of millions of years of evolution optimizing for life in the sunlight. But this is just the beginning. Because below 200 meters, the rules change. Welcome to the twilight zone. 200 to 1,000 meters deep. Light still penetrates here, but barely. It's dim, blue, fading with every meter you descend, and the sharks here start looking different. Take the 6-gill shark, blunt-nosed 6-gill to be specific. It can grow to 16 feet long, but unlike great whites, it's not streamlined. It's thick, heavy, almost sluggish in appearance, and it has 6 gill slits instead of 5. That extra gill slit isn't a deformity. It's ancient. Most modern sharks lost the 6th gill millions of years ago because they didn't need it. Plenty of oxygen at the surface. 5 gills work fine. But in the twilight zone, oxygen levels drop. The water is colder, less dissolved oxygen. So the 6-gill kept that extra slit. More surface area for gas exchange. More efficiency extracting oxygen from oxygen-poor water. It's a feature from 200 million years ago. Retained, perfected. Because down here, it's an advantage. And then there are the eyes. Massive, disproportionately large compared to surface sharks. Because in the fading light of the twilight zone, bigger eyes mean better vision. More photoreceptors. More light captured. The 6-gill can see in near total darkness, hunting prey that surface sharks would never detect. But the twilight zone has another adaptation, even stranger, bioluminescence. The kitefin shark, discovered glowing in 2021, is the largest known bioluminescent vertebrate. It emits a faint green glow from photophores embedded in its skin. Why? Camouflage, counter-illumination. When predators look up from below, they see the shark's silhouette against the faint light from above. But if the shark glows with the exact same intensity as the background light, it becomes invisible. The silhouette disappears. It's camouflaged by matching the light, not by changing color. And it only works in the twilight zone where light is faint but present. This is where sharks stopped looking like surface predators and started looking like something designed for an alien planet. But we're not even halfway down yet. And before we descend into the true abyss, where sharks become living fossils with features so ancient they shouldn't exist, where bodies turn gelatinous and jaws become projectile weapons, make sure you're subscribed. Because what's waiting below 1,000 meters isn't just weird, it's the result of 400 million years of evolution pushing life to the absolute edge of what's physically possible. You won't want to miss this. 1,000 meters? The midnight zone. Sunlight is gone, completely, permanently. The only light comes from bioluminescence, creatures making their own glow in the infinite black. Temperature hovers just above freezing. Pressure exceeds 100 atmospheres. For every square inch of your body, the ocean is pressing down with over 1,400 pounds of force. And the sharks here look like they were designed by someone who'd never seen a shark before. The goblin shark, possibly the strangest looking shark on Earth. Pink skin, not gray, not blue. Pink, because at this depth, camouflage by color is meaningless. The pink comes from blood vessels visible through translucent skin. Its snout extends forward like a fleshy blade. Flat, covered in electroreceptors called ampullae of Lorenzini, thousands of them detecting the faint electrical fields generated by living creatures. In total darkness, the goblin shark doesn't hunt by sight. It hunts by sensing your heartbeat through the water. And then there's the jaw. Most sharks bite by lunging forward. The goblin shark doesn't need to. Its jaw is slung beneath the skull on elastic ligaments. When it detects prey, specialized muscles release like a spring-loaded trap. The jaw shoots forward, 9 centimeters beyond the skull. In less than a third of a second, teeth close around prey. Jaw retracts. It's a biological projectile weapon. And we only discovered how it worked in 2007 when someone finally filmed it feeding. For over a century, we had specimens, dead goblin sharks, in jars, and we had no idea their jaws could do that. But the goblin shark isn't the only Midnight Zone nightmare. The frilled shark, eel-like body, 6 feet long, with a head that looks like a snake and a mouth full of teeth arranged in 25 rows. 300 teeth total, each one shaped like a tiny trident. It doesn't chase prey, it strikes like a snake, lunging forward and swallowing fish and squid whole. Prey half its own body length, disappearing down its throat in one gulp. And like the sixth gill, it has 6 gill slits, sometimes 7, ancient features retained because they work. The frilled shark looks exactly like its ancestors from 80 million years ago. Fossils match living specimens almost perfectly. It found a strategy that worked during the age of dinosaurs and never changed. Because down here, there's no evolutionary pressure to change, no faster prey to chase, no new predators to evade, just darkness, cold, and the same deep-sea squid that have been here for millions of years. If it works, why fix it? But these sharks, strange as they are, still have bones. Still have recognizable shark features. They're weird, but they're still sharks. Go deeper, and even that starts to break down. 2,000 meters, the abyssal zone. Pressure exceeds 200 atmospheres. Temperature drops to 2 degrees Celsius, and food is almost non-existent. Organic material, dead plankton, fish carcasses, whale falls, takes hours to sink from the surface. By the time it reaches 2,000 meters, it's been picked apart by scavengers at shallower depths. What little food makes it down is scattered across thousands of square miles of barren seafloor. Finding a meal can take weeks, months. So the sharks here evolved to become energy efficient to an almost absurd degree. The Greenland shark, one of the largest sharks in the ocean, up to 24 feet long, bigger than a great white. But unlike great whites, it moves in slow motion. Maximum swimming speed, less than 2 miles per hour, slower than a human walks. Its metabolism is so reduced that it can go months without eating, maybe longer. We don't know because we've never tracked one long enough to find out. But here's the truly disturbing part. They live for 500 years, maybe more. We know this because researchers analyzed growth rings in their eye lenses, like tree rings, but in crystalline tissue that accumulates slowly over a shark's entire life. The oldest specimen they tested? Over 400 years old. It was born before the Pilgrims landed at Plymouth Rock. It was already an adult when the United States declared independence. It lived through both world wars, and it's still swimming right now somewhere in the Arctic or North Atlantic, hunting seals in water cold enough to freeze a human in minutes. Longevity like this is possible because of the cold, because of the slow metabolism, because down here, time moves differently. But the Greenland shark also represents something else: deep-sea gigantism. At depth, animals tend to grow larger than their shallow water relatives: the giant squid, the colossal squid, the Japanese spider crab, and deep-sea sharks. Larger bodies lose heat more slowly, critical when you're living in near-freezing water with limited food. Every calorie counts, and a larger body with a slower metabolism is more efficient than a small body that burns energy quickly. The Greenland shark took this to the extreme: massive size, glacial metabolism, centuries-long lifespan. It's the ultimate deep-sea survivor, but it's not the deepest. Below 3,000 meters, we enter the Hadal Zone, named after Hades, the Greek underworld. This is the realm of oceanic trenches. Canyons in the seafloor deeper than Mount Everest is tall, and the sharks here are at the absolute limit of where vertebrate life can exist. The Mariana snailfish isn't a shark, it's a fish, but it represents the boundary. The deepest living fish ever recorded, found at 26,831 feet in the Mariana Trench. Below this depth, scientists calculated that vertebrate life becomes physically impossible. The pressure is so extreme that the proteins needed to build bones, muscles, and organs can't function. Even with protective chemicals, cells would collapse. The snailfish lives right at this limit. Any deeper, and biology breaks down. We haven't found sharks that deep. The deepest shark ever recorded is the Portuguese dogfish at around 12,000 feet, nowhere near the Hadal Zone, but still deeper than any human-occupied submersible regularly operate. Which means there are parts of the ocean where sharks swim that we can't reach, can't observe, can't study, and we have no idea what they look like. So why do sharks get scarier the deeper you go? Because the deep ocean doesn't reward beauty. It rewards efficiency, survival, adaptation to an environment so extreme that normal doesn't work. Surface sharks evolved to be fast, streamlined, built for chasing prey in open water where visibility and speed matter. Deep-sea sharks evolved to be patient, to sense electrical fields in total darkness, to have jaws that shoot forward like biological weapons, to live for centuries on a handful of meals per year. They retained ancient features, extra gill slits, eel-like bodies, primitive jaw structures, not because they're living fossils stuck in the past, but because those features are perfect for the deep, and the result is creatures that look alien, wrong, like something that shouldn't exist on Earth. But they do exist, right now, swimming in darkness so complete it has weight. In cold, that would stop your heart. Under pressure, that would crush you into nothing, and they've been down there for 450 million years. Longer than trees have existed on land, longer than dinosaurs walked the earth, longer than almost anything else alive today. The ocean covers 71% of Earth's surface, and we've explored maybe 5% of it. The rest is unknown, unmapped, filled with creatures we've never seen. Every time we send cameras into the deep, we find something new, something that rewrites what we thought was possible. In 2021, we discovered the kitefin shark glows. Before that, we didn't know any shark was bioluminescent. In 1976, we discovered the megamouth shark, a 15-foot filter feeder that somehow avoided detection despite living in relatively shallow water. In the 1990s, we found goblin sharks still existed in numbers we never imagined. They weren't rare, they were just invisible, living in a depth zone we rarely explore. What other sharks are swimming in trenches we've never visited, in underwater canyons we've never mapped, in caves and crevices thousands of feet below the surface? We don't know. And that's the truly terrifying part. Because here's the final truth. The sharks don't get scarier because evolution made mistakes. They get scarier because evolution perfected them for an environment we can barely comprehend. The goblin shark's projectile jaw isn't a nightmare. It's genius. The frilled shark's eel-like body isn't primitive. It's optimal. The Greenland shark's 500-year lifespan isn't an accident. It's the ultimate survival strategy. These sharks aren't monsters. They're specialists, masters of the deep, perfected over hundreds of millions of years to dominate an environment where almost nothing else can survive. And somewhere, right now, at 2,000 meters depth in absolute darkness, there's a frilled shark hunting, a goblin shark sensing heartbeats through the void, a Greenland shark that's been alive since before your great-great-great-great-great-grandparents were born. They don't know we exist. They don't care. They're doing exactly what they've been doing since before continents had their current shapes. And they'll keep doing it long after we're gone. The deeper you go, the scarier they get. Not because they're trying to be scary, but because down there, in the crushing dark of the abyss, evolution stopped caring what we think looks normal. It only cares what survives. Sleep well.